the where this arrangement is shown to you. Let me adjust a little. Yeah, that's fine. I think that's easily visible to you, right? Now, the question is that the coefficient of static friction between the block of 2 kg and table is given to you at 0.2, right? That means let us capture the data which I have already mentioned over here. The static friction mu s represented by mu s is given to you at 0.2 between the table and the block of 2 kg. So the static friction will be lying over here, right? This is mu s, right? I'm just highlighted it with corrugated type so that you can easily understand, right? Into this question, the second part is that what should be the maximum value of m so that the block do not move, right? So that means this block is not going to move. So for that, what will be the value of this mass? That we need to calculate, right? What is the value of this mass, right? So to solve this question, let us do, students, draw the free body diagram. Okay, the first step, step 1, is to draw the FBD, right? So when you draw the FBD, what will happen? There will be two FBD for mass M and FBD for this 2 kg mass, right? Let's say, and let us consider the string which is passing over here. Okay, if no data is given to you into the question, that means the string is light and smooth and frictionless, and here there is no friction over this point, right? Now let us say if T is the tension into this string, right? Let's say if T is the tension, if T is the tension into this string, right? If T into the tension into this string, this tension will be passing across this pulley and this will be like this. So here also there will be a tension. So there will be a conditions like that. The mass will be tending to move downward and this will be pulling and this will give a strain into the string, and this strain is passing over here T, and this tension is trying to pull this mass towards right. So in this case the static friction is holding this 2 kg mass to slide, right? So when you draw the free body diagram, the step 1, for the mass m, for the mass m, it will be like this, right? It will be like this. T will be acting upward, you can see, and the weight of this mass will be mg, isn't it? And this mg will be acting downward, right? And there will be no forces acting into the left and no forces acting into the right. So that's why from here we can just write that T is equal to, and yes, if there will be an acceleration, then it would be, the mass would be going with a acceleration, but here it's said that the for no movement this condition is applied. So we will write the equation when the mass will be moving also, then only this equation will be valid. Just write like that, right? So T minus mg, T minus mg will be or should be equal to m into a, though here a is 0, though here a is 0, but this equation is valid, this equation will be valid when the this mass will be moving or the block will be sliding. In both the condition T minus mg equal to ma will be valid. I am drawing the free body diagram of this mass, right? So since we know that a equal to 0, why acceleration is 0? There is no movement, right? When there is no movement, the initial velocity equal to final velocity, this will give you acceleration as 0, right? Since a equal to 0, therefore right RHS will be equal to 0, and this will give you t minus mg is equal to m into 0, right? So this will give you a relation t, my refill is finished, let me write, change the pen, t equal to mg. So this is one of the relation which you arrived, right? Now after this, what is the free body diagram of the second mass? This one, you see, this is a static friction, and the static friction or the friction force will be acting always opposite to the direction of movement, right? Though it is not moving, but if here it will be moving, then the A will be like this, right? A will be like this, and the value of A equal to 0, right? The direction of the acceleration would have been right hand side, right? So in this condition, when you draw the free body diagram of that 2 kg mass, of that 2 kg mass, then you can see T will be acting rightward, and the frictional force will be acting always opposite to it, so it will be acting into the left hand side, because this will be opposing the movement, right? And if there would have been some acceleration which we considered as a standard case, then ma would be f equal to ma would be like in the into the right hand direction. So this will be giving you, and here the frictional force fs will be acting into the left hand side, the static friction, right? So this will give you t, or fs minus t, fs frictional force minus this tension, that is the, that will be into the LHS, and this will be equal to the total MA, that is M into A, where M is 2, here M is equal to 2, right? So this will give you, since the acceleration over here is 0, because for no movement only we are solving this question, so in this case this A is equal to 0, right? So RHS will be equal to 0. This will give you Fs is equal to T, isn't it? Fs is equal to T, but Fs is equal to T, let me take another pen, but Fs is equal to T can be equated with this equation, equation number 1. Let's say this is equation number 2. So from 1 and 2 we can write, we can write we, let me slide a little, yeah, from here we can write Fs is equal to T is equal to mg by equation 1 and equation 2. So static friction, the value of a static friction will be equal to mu s into normal reaction, right? What is n? N is a normal reaction acting into the upward direction, right? That is perpendicular to the floor of the table, and this will be equated with the total downward force, which is equal to m into g, that is 2g will be compensated for normal reaction, so n will be equal to 2g, right? Hi Joyce, good morning. Yep, that's what 6:30 am did to the guy, and we didn't have to go 6:30 am. Yes, is it? Okay, actually here it's the time is in India, it's around let me see, Yeah, it's 755. So more or less we are approximately matched with the GMT. More we are plus 530, right? So mu s into n is the static friction into normal reaction. This will be the value of Fs, right? This is the value of Fs. So that's why this will be equated with m into g. This m into g. And here this n, you can see the total upward force will be equal to the total downward force. So this will give you n equal to 2g. N equal to 2g. Here you can see n acting upward and 2g acting downward. 2 kg is the mass of this. So m into g, n equal to 2g. So here we can write, since the value of a static friction, coefficient of a static friction is given to you as 0.2, right? So just put up the value. So putting up the value over here, right? Putting up the value over here, mu s is 0.2. So write 0.2, right? And what is the value of n? The value of n is 2g. Let's say this is equation number 3, right? So n equal to 2g will be like this, and this is equal to m. So this m is this mass, mind it, m into g. And from here you can see g and g will be cancelled out because all the terms into the LHS and all the terms into the RHS are in product only. So this will give you 0.2 into 2 equal to the value of mass, which will, when this mass will be there, then this will be holding this 2 kg mass to slide, right? So gm is coming as equal to 0.4 kg. Unless and until you apply a mass greater than 0.4 kg, this will not, this mass will not slide, this will not move based upon this static friction. That means this is holding it, right? So the hanging mass should be greater than equal to 0.4 kg, just in case if you want to move it, right? So that's why m equal to 0.4 kg is the value which is asked into the question. Students, I think you like the session for today, and yes, for any query you can write to me. Don't hesitate, just come forward. If certain query is there, definitely that will create a trouble and problem in future. Okay, so just clear the concept. Whatever I can, I'm trying to help you. Okay, but don't hesitate to write or chat or ask for any query. Okay, and thank you so much for watching. Bye bye students, take care.